So when we look at functions and function notation, we can use this to help us transform the function. So what we're going to do is take a look at this root function here. So we have this input value, x, and we have an output, y, based on this original root function. Okay, notice I just chose some nice numbers here. And as reference numbers, we should really choose nice whole numbers. So I use 0, 0. Input is 1, output is 1, input is 4, square root gives us 2, input is 9, square root gives us an output of 3, input of 16 gives us an output of 4. So this is what the square root function does. So this is the function, this table, this equation, okay? And we can actually look at the original graph here as well. This graph represents the original function. So we can change this function and transform it by doing a few things. What we can do is we can change the input. Okay? We can change this input to change the function. And we can also change this on the output here. So because the +2 is with the input, it has something to do with the x's, how we change x's. And since the -4 is on the outside, it's to do with y's, it has something to do with y's. And what's very important is that we need to keep the x's and y's completely separate from each other. They have nothing to do with each other. Well, I'll show you a diagram later where that looks like in the function flowchart, why they have nothing to do with each other. Once we establish the function, the x to y is done. Okay, the function part of it is done. This is our function part. Square root, that's the actual action on the x. Okay, so that x to y is done, and it's established as this table, as this equation, as this graph. So what does transformations look like? Well, the simplest way to look at it is, well, and you've seen this before, if I have a +2, okay, so I've got an x +2 in my inside, so that goes inside the square root or inside the function. So this issue of inside and outside. So the inside here is in the brackets. I put it on the inside of the function, which is inside the square root. So I'm just going to maybe highlight that. The square root is the actual function part of it. And that's going to affect the x. The -4 goes on the outside. It's outside of the f of x notation, so it's going to go outside of my square root. Okay, so again, I'm just going to highlight that blue part represents the function. So what's happening then, and how does this change my original function? Well, what's going to happen is when we do x's, and we've seen this with quadratics, x's work in the reverse. So if I go +2, it's going to go the opposite, backwards 2. Okay, so this transformation from here to here, do like this, from here to here. Okay, I'm going to take my original x, and I'm going to -2, and I'm going to get my new x, and that's going to be my new x here. This represents my original x. Okay, and notice I'm not doing anything with x and y's. It's just x's separate from y's, because that's what we want to do. X's and y's have no interaction with each other, apart from this here establishing the function to begin with. But once we establish the function, x's are separate from y's. So when I change my x's here, all these x's go backwards 2. So it goes -2, -1, 2, 7, 14. Okay, and we've seen this with parabolas. That +2 moved everything to the left. And this is what this -2 is going to do. It's going to move everything to the left. So it's kind of weird that it's backwards, but it is backwards. And one of the reasons, I'll give you a very brief explanation why it's backwards, is because what we really need to do is we need to somehow actually get back to this x, because this is my input. This is my function. This is the input of my function. So I need to get back to 0. So how do I get back to 0? Well, I can add 2 to get back to 0. I can add 1 to get back to 1. I can add 2 to get back to 4. So that's actually what's happening. I'll show you in a diagram how that looks a little bit more, makes a little bit more sense. But that's why everything's backwards with x's, because we're actually going this way. We're trying to get back to the input so that we can go from input to output. With the y's, we don't have to do anything backwards though. Y's are on the outside of the function. Okay, so we don't really need to worry about y's because y's can just go are done exactly as they were. So when I saw in a parabola -4, I went down 4 on the outside. So because it's on the outside, it's to do with y's, and y's are done the right way around. Okay, so I'm going to take this original y. Okay, I'm going to take all these original y coordinates, and I'm going to use my -4, and I'm just going to do this. My new y's are going to be my original y's -4. And notice again, I'm not mixing my x's and y's. I'm not putting it through this new function here. Okay, my function's already been established. My function is square root. I do not go from x to y that way. Okay, I went from x to y with my function here. So now all I'm doing is changing all my x's with the inside transformation. I'm going to change all my y's with the outside transformation. So I'm going to take 0 and go down 4. 1, down 4. 2, down 4. 3, down 4. 4, down 4. So since the square root x is my function, it's established here. This +2 -4 represents transformations. Transformations occur opposite for x, the right way around for y, and I get my new function here. So basically, this new function, if I track the coordinates, if you take a look at it, it's going to be, every coordinate is going to be to the left 2 and down 4. So if I take a look at my vertex, left 2, down 4. Every single point it's been done that. I can track all these points on my new graph too. -2, -4. Okay, -2, -4 is a vertex. Okay, -1, -3 is that coordinate right there. 2 over, -2 down is going to be this coordinate right there. 7 over, 1, 2, 3, 4, 5, 6, 7. 1 down is that coordinate there. And the 14, 0 doesn't actually show up, but it will be in the right part of the graph if I extend that graph. So this is a new way of looking at transformations and functions. We want to understand things in terms of function and function notation. We establish a function. It's established here, and in fact the algebraic calculation is not really relevant. It's really this table that establishes a function, and these transformations, inside is x, it's done backwards, outside is y, and it's done the right way around, and we do x's and y's independent of each other.